Hello students, today we are going to discuss the third numerical of indeterminacy of beams. Now in question it is clearly written as degree of static indeterminacy of the structure as shown in the figure is. It means that we want to calculate here the total degree of static indeterminacy for this structure which is shown on the screen. Okay, now I had named all the support, that is A, B and C. At support A and C there will only be the hinge support, and at support B there will only be the roller support. Okay, now in between A to B support there will be two internal hinges which is shown here like this. Okay, now we want to calculate here the total static indeterminacy. It will be the sum of external static indeterminacy plus internal static indeterminacy. Now we know that the external static indeterminacy will be equals to what? R minus S, where R is the total number of support reaction and S will be the total number of equilibrium condition. Okay, now in this structure at support A there will only be two reaction component, that is vertical and horizontal. At support B only one reaction component, that is vertical reaction, and at support C there will only be the two reaction component, that is vertical and horizontal. Now if we add all these reaction component then its sum will be equals to 5. Okay, now the loading is not mentioned in the question. So if the loading is not mentioned in the question, then we will go for the general loading case, and we know that for general loading case the equilibrium condition will be equals to 3. Now if we put this value, that is 5 minus 3 here, then its value will be equals to 2. That will be the external static indeterminacy. Okay, now we had calculated this external static indeterminacy equals to 2. Okay, now we want to calculate the internal static indeterminacy, but we know that if we have the external reaction values in case of beam, then we can easily determine the internal reactive forces. It means that the total internal static indeterminacy will be equals to 0. But in this beam there will be two internal hinges, so we need to subtract that value from the total internal static indeterminacy. Now which value is subtracted? The number of members connecting at each internal hinge minus 1 needs to be subtracted from the internal static indeterminacy. Now for this internal hinge, there will be two members connecting at this internal hinge, so we need to subtract here only 1. Okay, now at this internal hinge there will be two members connecting at this internal hinge, so we need to subtract also 1 here. Now the total internal static indeterminacy will be equals to minus 2. Now that will be the value of internal static indeterminacy of this structure. Now if we want to calculate the total static indeterminacy, then it will be the sum of external static indeterminacy plus internal static indeterminacy. Now if we put both these value here, that is 2 minus 2, then its sum will be equals to 0. Now that will be the static indeterminacy of this structure which will be asked in this question. Okay, that will be the complete solution of this question. Okay students, thank you very much.